This is your last lecture video for this class, so if you've made it this far, you should give yourselves a big pat on the back. All you'll have left to do is take this test and then take our final exam, and you'll be good to go. So hopefully you're doing really well, and these videos have been very helpful for you. So before we get to solving quadratic equations by factoring, I have a couple of jokes. What is a math teacher's favorite tree? A geometry. And why did the two 4s skip lunch? They already ate. Get it? 2 4s, 8. Okay, so, all right, last video, or at least last instructional video. Solving quadratic equations. So let's remember that the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. So before we have had expressions and we've factored those expressions. And what is the difference between an equation and an expression? Well, an equation has that equal sign in it, so that means we can actually solve it. The only thing we can do on an expression is either simplify it or factor it, and that's as far as we can go. We can only factor it. We cannot solve it because we don't know what it's equal to. So we say an equation has an equal sign in it because we can solve it. So when we are working with these quadratic equations and when we are factoring them, just notice that it must be equal to 0 before we factor it. And so our zero principle, product principle, means if a times b is equal to 0, so some number times another number is equal to 0, then one of those numbers, either the a or the b, has to be 0 in order for that to equal 0. So that's what we're going to do here, is what we're going to, from that standard form, which means it's got to be equal to 0, we're going to factor it. Well, we already know how to factor that, so that's sort of the hardest part. Then we're going to set each one of those factors equal to 0 and solve for each one of those equations that we created. Then, of course, you can always check your answers. Okay, so here is an example of one that's already in factored form. So I already factored this one for you. It's x minus 5 times x minus 2 is equal to 0. Well, notice we have the equal sign. It's equal to 0. So that means, it's an equation. It's already factored. So our next step was to set those factors equal to 0. Well, x minus 5 is one of those factors, and we're going to set it equal to 0. And x minus 2 is the other factor, and we're going to set it equal to 0. Then we're going to solve. So all we have to do is solve for x. So we're just going to add 5 to both sides. So x is equal to 5. And then we're going to add 2 to both sides over here. So x is equal to 2. So remember before we dealt with those linear equations, and linear equations were was when we created like a straight line in our graph. So if we had our coordinate grid like that, then we would just, our linear equations would look like that. But a quadratic equation is one that looks like those parabolas, is what we call them. So they look, they're that big U shape on here. So we have this quadratic equation that looks like that. So what did these solutions actually mean? Well, in this case, if we have solutions at 5 and we have solutions at 2, well, that means that it crosses this x-axis. That's where y is equal to 0 at both 5 and 2. Maybe I need to make that bigger. But so we know we have an x at 2. So I'm going to say, or a 0 here at 2. And we also have a solution here at 5. So that's 1, 2, 3. This one right here. So this quadratic equation, we know from this information is going to pass through here and look something like this. Now, we don't know exactly what the total shape of it is, but we know in general it's going to look something like that. And those are the zeros. So most of the time when we deal with quadratics, it means like they're going to be the opposite. When something goes up, it comes back down, like a golf ball or a rocket or an airplane or whatever. Well, this is the ground. So when we say that like y is equal to 0, well, this is where y is equal to 0 is like the ground, so we can't really go any further. But those are the 2 points where this object is going to hit the ground. And that's what those mean. So you don't need to know too much of that. I just wanted to give you that background information of what we're doing this for and why we're doing it. And so if you have any questions like that in your next class, you'll sort of have an idea of what we're talking about. Okay, so here's another example of one that is already factored. So we're going to set both of those factors equal to 0 and then solve for them. So we're going to subtract 1 from both sides. So 2x is equal to -1. Divide both sides by 2. So x is equal to -1/2. Now on the other one, if we add 4 to both sides, x is equal to 4. So notice most of the time we do have these two answers because they're going to cross that x-axis twice. So because they are that U-shaped. And then it's also another big hint that whatever this x, that degree of that polynomial, and we talked about that before, that those degrees are that highest number, that highest exponent that's throughout, that's usually how many possible zeros we're going to have. Okay, so when we're dealing with these x squared equations, then it's going to cross that x-axis twice. Okay, so let's look at one now. We've got to do the whole thing. We're going to have to factor this. So x squared minus 6x plus 5 is equal to 0. And remember our factoring strategies. First off, we look for GCF. Well, we don't have one of those. Next thing we do is we look at the number of terms. We have 3 terms, so we can either use the big X method here, or we can just go straight to the C term and come up with products of C that add up to be the B term because of the 1 that's in front of that x squared. There's no number in front of there. All right, so what times what is equal to positive 5 that adds up to be a negative 6? So hopefully we're getting better and better at this factoring, but that should be negative 5 times negative 1. So negative 5 times negative 1. Yes, okay, so we're going to set up our factors now. X minus 5 times x minus 1 is equal to 0. And that product rule says so either one of those could be equal to 0 in order for that whole thing to equal 0. But we set each one of those factors equal to 0 and we solve. So x is 5, add 1 to both sides, x is 1. So the tendency, once you know how to do this, is to go add equal signs in on your other equation or expressions where it just says to factor, and sometimes people will go ahead and go solve them. And just keep in mind, you cannot solve these equations unless they have an equal sign in them. So if it's just an expression, then make sure you only factor it. So what times what's negative 25 that adds up to be a negative 10? We only have factors of negative 25. There would be 5 times 5, but nothing would be negative 10. Because one would have to be positive and one would have to be negative. So if it cannot be factored again, remember it is prime. That may have been, should be a plus 25, but that's what I wrote. That's what we'll do. Okay, so this one is Again, he is not in standard form. So first off, we've got to put this one in standard form. Remember, it's got to be equal to 0 in order to factor it. So we're going to say that's 5x squared. We're moving that negative 2x over. Is equal to 0. Remember, in order to move him over, we're going to subtract him from both sides. Okay, well this one is still not in the standard form like above, but we do just have two terms. And what's our first step always in factoring? Look for a GCF. Well, we do have a GCF of 2x. So let's take that 2x out, and we're going to have 2x minus 1 left. Okay, well, each one of these, this is still a factor of this quadratic equation. This is also a factor. So we're going to set each one of those equal to 0. So 2x is equal to 0, and 2x minus 1 is equal to 0. Well, if I divide both sides by 2, that means x is equal to 0. If I add 1 to both sides, then divide by 2, so x is equal to 1/2. So x is equal to 0 and x is equal to 1/2. And remember, that's okay, because that just means it's going to cross at the 0. And let's say that's 1, that's 2. And it's also crossing here at 1/2. So this parabola looks something like that. All right, let's try a couple more. So again, it must be equal to 0 in order to factor it. So we're going to move these other items over here. So 9x squared minus 30x is equal to negative 25. We'll still add the 25 to both sides. Just notice these are not like terms, so all we can do is put them in the correct order. So we have, let me bring him over here so that we have got room to factor him. 9x squared minus 30x plus 25 is equal to 0. Okay, well those are some big numbers, but I don't see a GCF in there. So we are going to have to use our big X method here, and it looks like we're just going to have something really big. 9 times 25 is 225, and that needs to, so negative 30, our B term is down at the bottom. We're going to divide both sides by 9. So now we've got to come up with what are all the factors of 225. So let's see. I'm just going to have to play on my calculator here. So 225 is 15 times 15. Oh, and they're both negative, so that looks like they'll both work. So negative 15 times negative 15 makes positive 225, and negative 15 plus that negative 15 makes negative 30. Okay, remember, we reduced these, so that's going to be negative 5 over, let's see, dividing both by 3, so negative 5 over 3. They will both be that way. So remember, bottom number moves to the front of our binomial. So 3x minus 5 times 3x minus 5 is equal to 0. Set your factors equal to 0 and solve. Well, we're going to get the same answer because we've got the same binomial, and that just means that it doesn't cross. It just comes down and touches at that point, because we do only have that one solution, because we would get the same answer if we solved this one. So x would still be 5/3, which if you were going to see a graph, let's just say right here is 5/3. That by quadratic would look something, just come down and touch it right there. That's why it doesn't cross it, so that's why you only have the one answer. Okay, so last example, let's just make sure we remember these things have to equal 0 before we factor them. So even though this is written in two binomials that look like it's factored, that's not good enough. We've got to get that 28 over to the other side. Well, the only way we can do that is if we multiply out these two binomials. So we're just like throwing everything we've learned this whole semester in this one equation. So x times x squared. X times negative 2, negative 2x. Negative 5 times x, negative 5x. Negative 5 times negative 2, positive 10. And that's all equal to 28. So we're going to combine those like terms. We get x squared minus 7x plus 10 is equal to 28. Well, we still have to make this thing equal to 0. So we've got to move this 28 over. And he can only be combined with that other constant. So that gives us x squared minus 7x is equal to 10 minus 28 is, whoops, not equal to, sorry guys, minus 18 is equal to 0. All right, so now what times what? We're ready to factor it now. So we had to have it equal to 0 so we can factor. Because now it's in standard form. Okay, so all of that just to get to this point. All right, so let's think about what times what is 18 that adds up to be a negative 7. Well, I think negative 9 times 2. Oh, that makes negative 18, right? So negative 9 times 2 is negative 18, and negative 9 plus 2 is negative 7. So we've got x minus 9, x plus 2 is our factors. Remember, we set those factors equal to 0, and then solve for each one. So x is equal to 9. Subtract 2, x is equal to negative 2. So those are those solutions. All right, good luck on that. We'll talk again about the final exam. We just check out your reviews for your Chapter 6 exam, the reviews for the final exam, and we should be on the home stretch. So good luck, guys.